Now, if we look at how we can provide insights into the different services, so in the case of where you may be running a SCADA, separate set of VRFs to an IT network, I know that's really common in a lot of our utility customers, and the ability to come in here, in this case, that same map that we're looking at, but in this case, we want to look at the overlay for the SCADA network. So we want to see where it is featured out on this one. I'm going to come up here to the search bar, and I'm just going to type in SCADA. It happens to be the name of my L3 VPN. You'll notice it shows me also VRFs, all the different interfaces that have been configured for, but in this case, I'm just going to drill to this L3 VPN homepage. And what that provides me with is now a topology map showing me here with each of these PEs identified here with the little arrows of where that SCADA network is configured as an overlay on top of my network. All of the links and devices between those nodes is the mesh that is being used to communicate from those edge nodes to edge nodes, from the substations to the other substations. What this provides is a very quick high-level view of how that network is performing. And now within that VPN, we can do things like path lookups. We can do troubleshooting only related to the set of addresses that are inside of that layer 3 VPN, for instance. In this case, we had a customer having a problem in New York. There were some automation systems that were measuring information in New York and sending that telemetry back to Dallas, and they were noticing that it would fail, that the automation systems would start showing offline, and we'd have to go back and try to figure out what the control system needed to do to reset. They were, of course, blaming the network, and we had to dig into that. So in this case, I'm going to enter a source destination just as I did before, but we'll be looking at a set of private addresses that were inside that VRF, so going from 10.2.2.2 to 10.1.1.1, and actually highlight then the path for that from JFK to DFW. So we can actually show here, moving from New York out to Dallas, this is the particular path. Just as I said before, we can hit the play button. This is available on every screen of the product. When I hit that play button, we'll see over time that the path moves from the gray line here where it was going to Dallas, suddenly it's going to LA. That makes very little sense. Why would the set of addresses suddenly change from one to the other? We can actually look into the path. So here we're going back in time, seeing exactly what was happening on the network, and it appears that the previous address was being advertised by Dallas, the Dallas router. It was as a /24, and then suddenly shifts to LA with a /16. Somebody, in this case, we can tell there was a configuration change. It happened at the edge node, and then we can go and see exactly what that particular issue was. In this particular case, we can see that at that time, the path has changed to LA. We can see that there's a number of what we expect to be up and running inside the VRF, the layer 3 VPN, that are actually down. We know this because we baseline them and can know what we expect to see. So when things disappear, we can alert to that. In this case, there's still 25 active routes. That means the device is still talking to us, but there's 18 that aren't advertised anymore. That tells us that something's changed in the configuration, and we need to talk with the guys that control the DFW PE router and make sure that the configuration change they made, they understand the impacts that they've had to these systems. So very rapidly going from, hey, we have this intermediate problem, we can't really tell what's going on from the network perspective, down to, hey guys, it's a particular change that happened in the Dallas router in the data center, let's go back and make sure that we don't have those kinds of problems again.